So blobs come in different shapes and sizes. So there are two fundamental kinds of blobs. They're not all just files in the cloud. The two significant kinds of blobs are divided into block blobs and page blobs. Block blobs are the ones that you're probably dealing with most commonly if you're dealing with things like putting JPEG files in the cloud, or a AVI movie, or an MP4, or maybe software downloads, HTML pages. Any of these can go in the cloud, and they typically be blocks. And there are page blobs as well. And the difference is the block blobs came out originally, and then they released this thing called a page blob when they talked about, when they announced the release of what they called the Windows Azure Drive. So this is the ability to add a durable disk drive to a virtual machine. Back then it was web roles and worker roles and VM role. And you could add and the drives on those are not durable. You could add a durable drive using this Azure Drive thing, and it's backed by blob storage. So it's very robust. Now, the use of block storage for that, Azure blocks for that, would be a fairly inefficient and it just was a non-starter for them to back a drive with blocks because the I/O patterns are so different. So they released a different kind of blob service that is based on what they call page blobs, that is optimized for random access, reads and writes, so all over various parts of the drive, like you would all over the blob, like you would expect from a disk drive. A disk drive
go ahead.
Jumps from here to there to
I'll go.
to download data or to write data, and these are that's exactly what they've done here. So if we look at briefly at the Azure Drive, go into this data management thing. Various kinds of data management. Tables is what we talked about with in the context of, this is also in a storage service. Blobs, we were the main theme. And then you can easily mount the blobs as drives. And basically, it appears to you as an NTFS virtual, an NTFS volume. Enough about that, I guess. And similarly, when I showed the very first slide that showed the high-level capabilities, or the first, the homepage of the WindowsAzure.com, one of the high-level capabilities was Azure Virtual Machines, which I talked about as similar to what Amazon Web Services offers, infrastructure as a service.
No,
and those drives are by default all backed by page blobs, so that they are durable. That's kind of a big important feature as well.
Exactly.
So blobs make
yes, sir.
The Azure Drive and the Azure Virtual Machine possible. So that's 1 out of 7, 2 out of 7. Yes?
Okay. What did they look?
Yep, absolutely. Done. No worries, no worries. Look at that. Blobs and HTTP headers. So I mentioned that blobs are, the blob service is a file system in the cloud. But they're also HTTP objects. All blobs are accessed through a REST service, through HTTP, XML over HTTP, and using just regular internet protocols, HTTP or HTTPS. So it's important to think about them as HTTP objects. In particular, a common one to overlook is to serve up a blob, give out a URL to a blob, only to do so without applying a caching header. Let's take a brief look at this. So I say that blobs are available as HTTP objects. They're also available programmatically. So there's an Azure Sdk offered by Microsoft. Let me very briefly bring that back. So if you go back to the portal and you click on develop, you can choose the programming model that you care about. There's also PowerShell, not listed here. And I'm a kind of a C# hacker, so I'd pick on the .NET one, not the Node one or the Python one, for example. And there's an SDK here, and I can install the SDK. And the SDK is language bindings, in my case, C# or .NET more generally. I could access it from VB.NET or F#, for example. And it's bindings that, behind the scenes, call the REST APIs. So if we looked at an interaction with Fiddler, say, we would see the network traffic when we use the C# language bindings. Similarly with PHP or whatnot. So I want to bring up a particular code snippet here with that in mind. And this very simple code snippet here shows setting of a caching header. So this is .NET SDK, Storage SDK 1.7. There's some boilerplate code. I'm not going to really show I'm not going to talk about the gory details of a lot of the code because there are great examples on the Azure website. But I do want to call out some particular idioms here. So in this particular example, this is some code that is before doing a file upload of a blob, taking a file from the local file system and doing an upload into Azure. It is setting a couple of these properties on it, and these should look familiar to any. First one certainly should look familiar to any web developer, whereas a content type. So this is a blob property, but it gets translated into the HTTP content type header. So that, the MIME type, so that you know what it is that you're uploading or downloading. And similarly, this is how you would express a cache control header for blob storage. And this one here is set for that max age is 1 year's worth. So if you wanted to cache if you wanted the internet to know that it can cache your company logo ping file for up to a year, that this is how you would express it, basically. So there are two kinds of attributes that you can apply to a blob. There are properties and metadata. And either of these properties and metadata can be accessed independent of the blob. So if you had a 100 megabyte video or a 100 gigabyte video, for that matter, and you wanted to get at its metadata or properties, you can ask for those without having to download the entire video file. So the kind of the logical mapping here is what Azure calls a property is kind of standard HTTP stuff, and metadata is extra stuff that you can create. And we'll take a very brief peek at that. So this, again, the little inflow code snippet. A property like content type, you can set it to any valid MIME type there, and you call the set properties method. And the set properties method results in a HTTP call back to the server. This rest of the stuff doesn't actually result in a HTTP call back to the server. So this set properties results in a call to the REST services. And then metadata. So this is stuff that you won't recognize because I just made it up. The job ID or source file name, maybe the source file from the client, when it was uploaded in client time. Like I said, just these can be whatever you want. And it's just a string and a value. And then blob.set metadata will result in a REST call back to Azure Storage to update the blob data with these new values. All right. How are we doing? If there are any questions, certainly give a shout or make a text message or something, and we'll stop and address any questions. So blob economics. So there are 3 different kinds of costs to be aware of when you're doing a cost analysis around the use of blob storage. The 3 costs are the at-rest cost. If you're not using it, you're just using up storage. Transaction costs, if you're interacting with it. And bandwidth costs, if it's traversing data center boundaries. let's take a quick peek at those.